Title: What if we've already found alien life and missed it? For decades, humanity has searched the cosmos for one answer. Are we alone? We've launched robotic explorers across the solar system, built giant space telescopes capable of analyzing distant worlds, and developed increasingly sophisticated instruments designed to detect the faintest signs of life beyond Earth. Yet, despite all this effort, the universe has remained stubbornly silent. Or has it? According to a new study published in Nature Astronomy, scientists are raising a deeply unsettling possibility. The greatest obstacle in the search for extraterrestrial life may not be that life is rare. It may be that we're simply failing to recognize it when it's right in front of us. In other words, alien life could leave behind unmistakable evidence, and we might still completely overlook it. If that's true, some of humanity's most ambitious space missions could be searching the right places, using the wrong assumptions. To understand why this matters, we first need to understand how scientists actually search for life. Very few researchers expect to find little green creatures walking across the surface of another planet. Instead, they search for biosignatures. These are clues that living organisms may have existed or may still exist. They could be unusual gases in a planet's atmosphere, complex organic molecules, distinctive mineral formations, or chemical patterns that, on Earth, are strongly associated with biology. If enough of these clues appear together, scientists begin asking an extraordinary question. Oh, could life have created them? But interpreting those clues is far more difficult than it sounds. Neither way, for years, researchers have worried about something called a false positive. That's when nature produces a signal that looks biological, but actually has a completely non-living explanation. Imagine seeing smoke in the distance. Your first thought might be that someone started a fire. Later, you discover it was simply fog illuminated by sunlight. You believed you found evidence when you hadn't. Scientists have spent decades developing methods to avoid making exactly that kind of mistake. But the new research argues that we've overlooked the opposite problem, a false negative. Imagine walking through a forest looking for birds. You never hear them. So you conclude the forest is empty. Later you discover the birds were there all along. They simply sang at frequencies your ears couldn't hear. The life existed. The evidence existed. The limitation was in the observer. According to the researchers, this exact problem could be affecting our search for life throughout the universe. Some biosignatures may disappear over millions of years. Others may become buried beneath rock, ice, or dust. Sometimes the signals are simply too faint for today's instruments, and sometimes the evidence is present. But we don't recognize what we're looking at. That possibility may be the most concerning of all, because, unlike a technical limitation, it challenges the assumptions behind the entire search. Imagine microscopic organisms living just beneath the surface of a planet. If your spacecraft only studies the rocks from above, those organisms remain completely invisible. You may return home believing the planet is lifeless, not because life wasn't there, but because you never looked in the right place. The researchers argue that future missions must be designed not only to search for life, but also to ask an equally important question. How could we accidentally miss it? The shift in thinking could fundamentally change how future space missions are planned. Traditionally, scientists begin with a hypothesis. They decide which biosignatures they expect to find. Then they build instruments designed specifically to detect those signals. That approach has been incredibly successful across many fields of science. But when searching for something we've never encountered before, it comes with an obvious risk. We naturally search for life that resembles life on Earth. What if alien life doesn't? Imagine trying to find fish while searching only in trees. No matter how carefully you look, you'll conclude fish don't exist, not because they're absent, but because your search began with the wrong assumption. The researchers argue that astrobiology faces a similar challenge. We understand only one example of life, our own. Everything we consider a biosignature. Every chemical pattern, every biological process, comes from a sample size of exactly one planet, Earth. If life evolved differently elsewhere, its fingerprints could be entirely unfamiliar, and we might overlook them without ever realizing it. Wonder you see, artificial intelligence. Modern AI systems excel at finding subtle patterns hidden inside enormous datasets. Patterns too complex for humans to recognize, rather than searching only for specific biosignatures. Future AI could examine planetary data more broadly, looking for unexpected relationships that don't fit known geological or chemical processes. Instead of asking, does this match life as we know it? AI might ask, why does this pattern exist at all? Sometimes, that difference in perspective could prove crucial. Imagine we conclude a distant moon is lifeless. Years later, human missions begin mining its resources. Only afterward do we discover microbial ecosystems hidden beneath its surface. By then, those ecosystems may already have been destroyed. The researchers warn that decisions about future exploration and eventually space mining could depend on correctly identifying life before human activity begins. Missing life doesn't simply delay discovery. It could erase the very evidence we hope to find. The study points to an intriguing example from Mars. Scientists recently identified unusual iron-rich minerals whose oxidation patterns differ from surrounding rocks. Here on Earth, similar oxidation patterns are often associated with biological activity. Does that mean Mars once hosted life? No one knows. The researchers are careful not to make that claim. Instead, they argue something even more important. If we fail to investigate these unusual patterns, they could eventually become another false negative. Not because they definitely indicate life, but because failing to understand them means we may never know. It's about the limits of human perception. Throughout history, science has repeatedly discovered phenomena that existed long before we had the tools or the imagination to recognize them. Radio waves, bacteria, exoplanets, gravitational waves, dark matter. Nature wasn't hiding them. We simply didn't know how to see them. The search for extraterrestrial life may be entering a similar phase. The greatest discovery in history may not require building larger telescopes alone. It may require asking better questions. Across the Milky Way are hundreds of billions of stars, and potentially trillions of planets. Some may be barren, some may host oceans, some may have developed chemistry unlike anything found on Earth, and somewhere among them, life may already exist. The challenge isn't simply finding it. It's making sure we don't overlook it. Because perhaps the greatest mystery isn't whether we're alone in the universe, but whether we've already encountered the evidence and failed to recognize what it was trying to tell